Experiment 1. For a fixed mass of gas, we are going to study the relation between gas pressure P and volume V at the constant temperature T. The procedures are: first, connect the syringe to the Bourdon gauge by using rubber tubing 膠管. Next, push the pistons into the syringe slowly to a certain position, and then record the volume of the gas V and use the Bourdon gauge to measure the gas pressure P. Next, change the position of the pistons. Lastly, record the corresponding values of P and V. There are some precautions or improvements in the experiment. Do you know why we need to push the pistons slowly? It is because only when we push the piston slowly, the temperature of the gas will remain constant. In order to have a fixed mass of gas, we need to prevent gas leakage. How? This can be done by lubricate or grease the junctions with oil. There are different places have junctions. This one, and this one. Also, the tubing, the rubber tubing used in the experiment should be short, 非常之短. Why? Because in the experiment, we only measure the volume of the gas V inside the syringe. The volume inside the syringe is V, and we get the volume inside the rubber tubing, V pi. In order to get V pi, the rubber tubing should be very short so that the volume inside the rubber tubing, V pi, can be negated. The experiment results shows that we have different sets of values of V and P. V1, P1, V2, P2, up to V5, P5. If we plot the data points on a graph of P against V, we will get a graph like this one. Which shows that when the volume of the gas increases, the pressure of the gas decreases. Now, if we add a set of data for 1 over V, 1 over volume, we got 1 over V1, 1 over V2, 1 over V3, 1 over V4, up to 1 over V5. And then we plot a graph of P against 1 over V. The data point will be something like that. And we get a graph which is a straight line passing through the origin, which shows that the gas pressure is proportional to 1 over volume, P proportional to 1 over V. That means the pressure of the gas is inversely proportional, 反比, to volume V. Or we can say the product of pressure times volume is a constant value. And this is called Boyle's law. if we have P1 and this is V1, and we have this is P3 and this is V3, for example, by using Boyle's law, which means the product of PV is a constant value. That means P1 V1 equal to P3 V3, etc. If three of the values are given, then we can find the unknown. Question number 1. An ideal gas in a container of volume equal to 150 cm3 has a pressure of 10 to the power 5 Pa. Find the pressure in the container if the volume changed to 75 cm3. State two assumptions in the calculation. By using Boyle's law, we have P1 V1 equal to P2 V2. Therefore, 10 to the power 5 times 150 equal to P2 times 75. Therefore, we have the new pressure P2 equal to 2 times 10 to the power 5 Pascal. Very easy. The assumptions are: first, assume fixed mass of gas or low leakage of gas. Second, assume the temperature remain constant. Second question, the gas inside the container, the volume original is V, is at a pressure P of 4 times 10 to the power 5 Pa. If the volume of the gas is double, that means becomes V pi equal to 2V. At constant temperature, find the pressure P pi of the gas. Again, by Boyle's law, we have PV equal to P pi V pi. That means 4 times 10 to the power 5 times V equal to P pi times 2V. That means the new pressure becomes 2 times 10 to the power 5 Pa. Question number 3. A gas is expanded, that means the volume is increased at constant temperature. Which of the following sets of data for pressure P and volume V is deviated from the others? Deviate means 有所不同. This is Boyle's law because the temperature is constant. That means PV is a constant value. Okay, let's multiply each set of data. P times V, this one is 15. For this one is also equal to 15. And this set of data, the product is also equal to 15. However, for the last set of data, the product P times V is equal to 14. That means this set of data is deviated from the others. Question number 4. A gas cylinder, 氣樽 of volume 0.5 m3 has a compressed air 壓縮氣體 at a pressure of 4 times 10 to the power 5 Pa. The cylinder is used to inflate a balloon 充一個氣球充氣 to a volume of 0.8 m3 at a pressure of 10 to the power 5 Pa. Find the final pressure of the gas cylinder P double pi. State the assumption. Consider the case before inflation and after inflation. Before inflation, the product of pressure and volume is pressure of the compressed gas in the cylinder times the volume of the cylinder, which is equal to, after inflation, the pressure inside the balloon is P pi times the volume of the balloon is V pi, Also, we got the pressure inside the compressed gas P double pi and the volume of the gas cylinder V. The sum of these two equal to original PV. Therefore, we got 4 times 10 to the power 5 times 0.5 equal to 10 to the power 5 times 0.8 plus P double pi times 0.5. That means the final pressure of the gas cylinder will be 2.4 times 10 to the power 5 Pascal. Second part B. Find the largest volume of the balloon that can be inflated to a pressure of 10 to the power 5 Pa using the gas cylinder. In this case, we have before inflation, the product of the pressure times the volume is still PV equal to, after inflation, the pressure inside the gas cylinder and that inside the balloon will be the same, which is equal to P pi times the sum of the total volume of the gas cylinder, which is V, plus the largest volume of the balloon, which is V maximum. Therefore, we got 10 to the 4 to the power 5 times 0.5 equal to 10 to the power 5 times 0.5 plus V maximum. Therefore, the largest volume of the balloon that can be inflated will be equal to 1.5 meter cube. Question number 5. A gas is compressed at constant temperature. By using kinetic theory of gases, explain how the pressure changes. When a gas is compressed at constant temperature, the distance between the gas molecules and the container wall will decrease. But since the temperature is constant, the speed of the gas molecules will remain unchanged. So, the gas molecule will hit the container wall more frequently. Therefore, the gas pressure will increase. Part B. Can you draw a graph of P against 1 over V and P against V to indicate the above process? To show the process of a gas compressed at constant temperature on a P against 1 over V graph, it will be something like a line from this point towards this point. Since when the gas is compressed, the pressure will increase and the volume will decrease, therefore 1 over V will also increases. If the above process is shown on a graph of P against V, it will be something like this one. The volume is decreases because the gas is compressed, but the pressure increases.